I'm Taylor Open with More Than a Teacher, and I'm going to show you guys how to do this problem. That's one we get a lot of questions about, and it exemplifies a technique or a skill that we think is really important on the test. So basically with a function like this, you're either going to be given the option to FOIL a set of variables or to factor them. You really can take a problem like this either way, but most people are going to think that it's easier to FOIL starting out, so that's where we're going to begin. So if you were to FOIL, you would multiply the first two terms and the outer two terms, and the inner two terms, and then the last two terms. Now I'm just going to bring this side of the function down without affecting it. Now most people immediately see that the first terms over here are the exact same as the first terms over here, and that's not a coincidence on the SAT. When they do something like that, they're trying to push you in a certain direction. So when you see that x squared cancels out, you want to take that. And most people, I think, will understand that when you're getting rid of something, if you're getting rid of something that's squared or any kind of variable that's squared, that's going to be moving you in the right direction. So because the first thing over here, the first item on the right-hand side of the equation, and the first item over here on the left-hand side of the equation, because they lined up, and because we know that this foils into this, and this therefore factors into this, if the first thing over here is equal to the first thing over here, we also know that the last term over here should be the exact same as the last term over here. That's just an assumption that you are allowed to make on the SAT. When things start to line up, everything should correspond like in the exact same order, as long as you've written them in the appropriate order. So like foiling, first, outer, inner, last. This would really be all of your outer together in here. So first, outer, inner, and last. So what I'm allowed to assume is that m is actually equal to 8k. And I can table that for now. I can just take that out the same way that I took out the x squareds because I knew those were equal. I knew my last terms would be equal as well. Now because of that, the only thing I'm left with is the middle two terms here, the outer and inner terms, and the middle term over here. Again, this should equal these two together because you always combine your outer and inner terms whenever you're foiling. So now that I'm at this stage, there's a couple things I can do. People will take the algebra in a few different directions. It really doesn't matter how you solve this as long as you're being careful. I prefer to take the xk across, or the kx across, and have that cancel. Now once I'm here, pretty much everybody will do the exact same set of steps. They're going to get rid of x from both sides, and they're going to divide by -4. So that leaves me with 2 is equal to k. Once I know what k is, the question was asking for the value of m, and I know that m is equal to 8k's. Once I have that, m is equal to 8, and k is 2, m would just be equal to 16. And that's the answer they were looking for on this problem.